So, welcome everybody to Lecture 10, Databases and Information Systems. In the winter semester used to be 25 and now 26, and Happy New Year. So we will say something about your experiences with the last exercise sheet, which was a year ago, which was Web Applications Part 1. Robin, can you take a note? That's Part 1. The exam, in case you want to know, is on 17th of March. That's written in the HIS in 1 at 9 o'clock in the morning. We did not pick that time, the Prüfungsamt did, and last time I checked yesterday it was 172 registrations, and 20 people are committing exercise sheets right now. I hope the rest are doing them anyway. If not, you should start now. If you do it just for the exams, it will be too late, at least for 95% of you. So today, last time was Part 1, today is Part 2. So we will talk about JavaScript, make our web pages dynamics, vulnerabilities, and Unicodes. It's again, I hope you liked the last lecture. This one is also pretty exciting, I think, a lot of live coding. And the exercise sheet 10 is just take your exercise sheet from last time and make the web app dynamic. So the last time we did it the old-fashioned way, now we do it properly, or you can just take the master solution, proceed from there. And we will talk about the exercise sheet a little bit more. It will tie everything together, really everything. It will use a database, SQLite, Sparkle queries, JavaScript, web application, fuzzy search, everything. I think it's quite exciting. If you do one sheet, do this sheet, because it ties everything together. So, some excerpts. Fun to make a web server and eventually see it in my browser. Designing the website. Robin, here's another typo, was very cool, but also kind of addictive. I think that's a good kind of addictive. There are at least two times of addictive. I was surprised how simple it is to build a basic web server. We did it low level, right? I mean, of course, you can use a package which does everything for you, but then you don't learn anything. Really nice. I really like the live coding session. That's great. I also like it. Quite interesting to try all those things by hand. Easy to follow. Styling with CSS was fun. So was a lot of room to be creative. A bit difficult to understand due to the amount of text. Most of you like that there is a lot of text because it makes it clearer. Very enjoyable. I like some of you already were familiar with web development, others were not, and I think the exercise sheet was interesting for both. So today we will continue with this, and then in the next lecture I will, so if you make a particular effort, we will show some of your web apps in the next lecture, and also the master solution web app, which is quite nice. What do you want to do better or continue to do well in 2026? Do things consistently for university and sports. More cool things with friends, and of course stay healthy. More sports, stop smoking, getting my shit together. I wanted to reduce doom scrolling. Let's see, very good idea. Improve my sleep, just sleep longer, like 8 hours regularly. That would be a dream. More physical exercises to prevent back, neck, shoulder injury from sitting at a PC too much, and so on. So let's continue with the topic of today, JavaScript. That's a new programming languages. I will not go through all the slides as last lecture in detail. We will do a lot of live coding, and I will just show you how it works. And then for the exercise sheet or later for learning, you can just go to the recording and also see how I did the details. Reference on the slides, but I will not go through anything. So JavaScript is another programming, it's a regular programming language. It was designed for code that runs inside a web browser. You will see what that means. Nowadays, almost every web page contains JavaScript. You can also use it, it's a regular programming language outside of the browser, Node.js, there are also other frameworks. yeah, it's a fully fledged programming language. You can do everything with it, except of course in a browser you can't click on this button and then delete all files on the file system. So it runs with restricted capabilities. You can't, you are on a web page, you don't want the web page to access files on your file system or read your mails or do funny things. But it can manipulate anything on a web page, and we will see what that means today. So it's object-oriented, like most languages nowadays. It's called JavaScript, but it has basically nothing to do with JavaScript, except the name. It was a marketing move because Java was popular at the time, so let's also call it Java something. Even though I hear some whispering here and there, for some reason it gets amplified when it reaches my ear. It's speed similar to Python. It's interpreted, not compiled. There is a just-in-time compilation, which means you have code in a loop, which is repeated very often. Then it will compile that and execute the compiled code, but that's a different topic. So sometimes works, sometimes doesn't. Variables are untyped, but there is TypeScript. We will not talk about that today. We could do 10 lectures about JavaScript, and we will see examples of that here, a few. So yeah, it's a variable. You do the same thing for a string, a number, array, or map. You just don't say it. It's just from the syntax. System will figure out what you mean. But it's the usual stuff, right? You have variables, assignments. I will go through that very quickly. We do it live together. I will not give a full tutorial on JavaScript here. Just a few things which are particularly important for us here. So how do you declare a variable? You can write var in front. You don't, so this is, don't do it anymore. You can use let. When you do let, then the scope is strictly within your current code block, like in most other languages. Not for Python, you have curly braces for scoping. In Python, you have indentation. Or const, these two are basically the same, except const, you say this will not modified anymore after assignment. So choose one of these two, or not this one. You can also omit them, but you shouldn't do that either. Let or const are the ones which you should use. And then we have, so your website, let's very quickly go to the code here that's our code from the last lecture, and let's start with I just copied verbatim the code which we wrote in the last lecture, and this is this delay Frank is our file system, and I did not change the color of my, so I have to, this I forgot to do. Where's my, Robin, where's my, I'm confused. Where's my Lua in it? Here. Sorry, this is something I should have done beforehand, but it's 4 weeks. And so let me try again. Okay, that's the color we want for this course. So we have that web page. Let me quickly show that to you. That's our, so it's not working. This is the browser. This is this web server, the little web server we wrote last time. Let me show that to you as well, maybe, and open it here. I will not go through all of that again. Maybe make that a little bit larger. So that was the web server we wrote. I have to make that yet a little larger. Okay. And I just started it here, so we wrote a web server from bottom up, and it's listening on a port and everything. And now here I'm in the browser. If I go there, let me just very quickly show you what our web page did. So I could type something here, doof, search it, and it would compute the n-grams. And here you would see it receives the request for the web pages, also computing the 3 grams in this case and returning them back. So what we see here is a rendering of the HTML. Let me briefly show that to you again. And this is represented in the browser somehow. So if I go back on the slide, it says, where is that? Here. Document object model is how the web page is represented in the browser. So where's my browser now? It's here. So what I can actually do here, there's something called inspect in every browser, and let me just look at these elements here. So we have also seen that. So what I see here is the web page in the browser. So here's an H1 element. It's maybe a bit small down here. Let me try to magnify that a little bit. Yes. Now so I can look at individual elements here. Now, what did I do? Oh, now it went up here. Yeah. So here I have the web page. H1, that's just the heading. It shows me how it's rendered. It shows me borders and everything. Maybe you already found out about that in the last exercise sheet. So you see all the elements of the web page and how they are rendered. And what you can do in JavaScript, you can access these things. You can say, give me the first header and change its color to something else, or change its text to something else. So for example, you could do the following in JavaScript, and we will start with that in a second. Please give me the element from my web page which has this ID. We will talk about IDs in a second, and change its content to something else. Or you say, when somebody clicks on this, then do something. And now let's go right into the live coding and do that together. So we will now write JavaScript together. And the first thing we do, so JavaScript files have the suffix JS. And the first thing we do is just write something alert. Alert will create a pop-up box, and let's say Happy New 2026. So, which is the year that's just started. So now we have written our first JavaScript program, .js, simple enough. And now we have to invoke it. How do we do that? Well, we just, in our HTML, we write here script, and we don't want script.js, we just want to say, we called it search.js script. So now, when the web page loads, and let's just do that, and just to repeat some things from the last time, do I have to restart my web server? No, I didn't change. This is Python code. I didn't change anything about my Python code. I just changed something about the HTML. So I'm just reloading it, go to the network tab here, and now I see here search.js down here. It's again a bit small. Can I make this a bit larger? Yes, and if I go here, it says 200, alles klar. And it returned, let me go to the console. Yeah, it says the script from search.js was loaded. And by the way, we see the pop-up here, Happy New 2006. That's what the alert. But I get a warning here because I read search.js and it was returned as text plain, but it's actually JavaScript. We also know about that. I hope you remember some of this. Let me just put my Python code at the bottom of this. So I will not. So here we had the headers we return. Here we could say what. So if it ends with JS, then we return the right media type, and the right media type for JavaScript is. This is. Else if should be elif, and you please tell me if I do anything wrong. I think this line is now too long. Apparently it's not. It's just so I just said if the file I'm requesting ends with JS, then it should get application JavaScript. Do I have to restart the server? Yes, because I changed the server code here. So I'm just restarting it, reloading it, and now the warning should disappear. Layout was forced because That may cause a flash of unstyled content. Let's talk about that in a second. Okay, now I get these pop-ups. This is what you would do in the 70s or in 1870s. You don't do pop-ups anymore. Let's do something else. Or you shouldn't. If you get a pop-up from the web browser, you are on the wrong website. So this is shady websites do it. Let's do one more thing, which you haven't seen yet. Let's do console log. This is now like print. And the question is, where does this print? Do I have to restart my server? No, I'm in my web application. JS is loaded from there, so let me do that. And now I see it's printed here. So in the development console of the browser, there's like a screen, and whatever I danke Frank, whatever I print to console log, it appears here. So that's very good for debugging. It's not what a normal user can see, but you could see it if you just do F12 and go to this. Yeah, these two are very important. The network tab for just seeing which files were loaded, which time, with which return codes, and the console, very useful for debugging. And we will also use it a lot. If you have any questions, please ask, also in the Zoom chat, but I don't see any questions yet. Okay, so first thing, why doesn't this work? Yeah, I have to, it's not easy. So now we have written our first JavaScript program, first a pop-up box, now we have written something to the console. Now let's change our web page. Let's do the following, and as I said, document, there was this query selector, and maybe let's change the inner H, yeah, that's good. So it knew exactly what I wanted to write. So let's go to the HTML, it's here, and let's give this H1 thing here an ID. I can give every element of my web page an ID, and let's just call this one title. There's nothing wrong with that. So I can now address this element from my web page via title. And if I address an element in JavaScript using query selector means it selects elements from the web page. I could also select several, but here I will just select the one with ID. IDs have to be unique, so there must not be two with title now. Careful. So now I will say change the HTML, which currently is our first search engine, from whatever, no, it's this one, this wasn't the meta. Please change this one. So inside here is HTML, in this case just text. Change it to Happy New 2026. Do we have to restart our server? No, let's do it, and now the title will not change. Why? Good that we have the console here. The console is also good for error messages when you do JavaScript. And now you tell me what went wrong. Document query selector. When you will work on the sheet, prepare on the exam, you will get these errors. And the nice thing about JavaScript, like for Python, it's an interpreted language, so you don't get segmentation faults, something went wrong somewhere. You get very nice error messages. I could even click here in the browser, and it would take me to the source code, to line 3, but we can just go to the source code ourselves. So it said, this thing here returned null, which basically means it does not exist, yes? Very good. We have professionals in the room. We loaded and let's just see what that means. We loaded the JavaScript file before what? Let me explain. We are now in a world where things happen asynchronously. And this is very powerful, but also it's not hard to understand, but can lead to complicated behavior. When the browser reads this, it will actually just do this, process this line by line, which means as soon as it finds this, it loads the JavaScript and starts executing it, which means it will do this But it will do this right away, and this is very quick, which means it will look for something with ID title and change it, but we haven't seen that yet. So the browser does this when there's nothing there yet. And there are several things we could do. For example, we could move this to the end. Let's just see if that works. It does. That's one thing. So it's quite simple. I mean, all these things are quite simple, but put together they are quite complex. I can also do defer here. There are all these funny keywords. Defer means do not start it before the whole page has loaded. This should have the same effect. Okay. Layout was forced. Do you know how to fix this? I don't know, maybe in the break I will find out. I don't like warnings in my log, but we will just accept it for now. Okay, so I hope you appreciate that we have made some progress. We have written JavaScript, we have included it, we have even changed something here. So let's keep the Happy New Year there. We change the title, we log it on the console. We don't do pop-ups, that's last millennium. Now let's do the next thing. Now comes something which is typical for JavaScript. I want, whenever I type something here, to do something. And the first thing I want to do is just right now nothing happens when I type something here, right? I have to do search. And then that's the static thing with forms, what we did last time. And let me just that was the question mark, should not be there. What I want now is I type something here, and for every action I do something. That's very typical for dynamic web application. And you do that with not with a query selector, but with an event listener. And what I want is, you have to know the syntax, so I say whenever something happens in the input field, there is only one input field. Actually, I think let's just do that. Whenever something happens in that input field, and now I want to say, do the following. And now comes a new concept. Do the following, it's a function, so in JavaScript you have anonymous functions. So this says, whenever something happens in that input field, now execute the following code, which I'm going to write now. And now, this is, I'm calling something. When something happens to me, I call this function. It's an anonymous function. I can also declare it outside, but I declare it right here in this argument list. And when this is done, then and here's something which is very typical, which you see. So there's a function. This curly brace is the closing curly brace of the function call, and this closing parenthesis, the closing parenthesis of this. So this is a pattern. It's very typical for JavaScript. And now let's do the following. So whenever something happened in the input field, let's first read the query. So the query is, so what do we want? We want to read and let's give this, here it's called query, let's call this input. So this first input field, let's just read its value. I gave it the ID input, and let me just say, I got a suggestion here which is wrong. These AI suggestions are useful for saving typing, but they're usually wrong. You still have to think. That's a different topic. Give me the query. This is value. You have to know all these syntax things, but you can look those up. And let me just log it to the console. User, I don't want, let me just call it query. So now, what did I do? Whenever I type something in the input field for every single action, which is right now typing something, get the query from the field, log it to the console. Do I need to restart my web app here, my server? No, I just changed something in the JavaScript HTML. Let's see whether that works. Blah, blah, blah. I typed something, not bad, right? It logs on the console. So it's already getting the very simple stuff. I'm already getting cool behavior. Okay, now let's go back to the slides. So I'm hopping. So this is what we did. We wrote some JavaScript. We accessed things from the web page, like give me something, or do something when something happens somewhere. Yeah, this we also talked about. You just have script tag. You put it here with defer. We have seen that will be executed. Yeah, I told you that. Now, what do we actually want to do? So let me quickly recap from the last time. How did this work? Doof. I type something here. I mean, right now it's logging on the console, but that's all the JavaScript does. Please recall what we did in the last lecture. I click on search. What happens then? Then this thing here gets a request for this, and it actually gets this input field. That's how we implemented it. And then it will return the whole web page again, but with a result in it. I hope you remember that part. Let me just, I don't have time to go through all of that again. But what we did here is we read the whole file again, and then we had some templates in here. Let me show those to you again, like result or even query. We will move them anyway. Put the result here and return back the whole web page. So this is like the old-fashioned way, static HTML, and there was a form field. In case you missed that, you have to understand it to understand the next level. So let me do that, and I had to click search. So this is what we did, and now the URL changed, and we have like a new web page. We loaded the whole web page again. I also showed you last time. Let me do that again. If I go to Google, it's exactly what Google does, right? Type Uni Freiburg. Now I have this is google.com or google.de. I go here. It loads a new web page now with search result. So this is still done. Now we want to do it JavaScript style. JavaScript style means whenever I'm back in the JavaScript, something happens in the console. We want to take what's in the input field and send it to our web server. Just this, and get the result back, not reload the page. Let's see how that looks like. And all these, as usual, these individual things are simple, but in combination they are complex. So now I want to send something, and I will just do it here. I will do, so I will send something, and now I will, how did I ask my, I think we did it like that. We don't, I just use this as the typing aid here. This is wrong, but I'm just explaining things also written on the slides, but let's do it in code. Now I say, please make this call. This is like I would enter this in the web browser. I don't have to write the domain, which was Tura 888. Everything happens in this context here. I don't have to repeat that again. This is called the domain of the web page or host, and this is the path. So I just have to specify this here. So now I say, please get me the contents of that. This will generate a request to this thing over here, and we should see that. So const response is this. And now, now there is, so you have to know the syntax. Now there's something else to understand. And I will first explain it in the code and then quickly go through the slides. In which order do I do it? Let me go to the slides and then back to the code. This is very typical. You do something in the browser, and now I want to communicate again, maybe with my own server or with other programs. And you do that with fetch. And this can take time now. A fetch can take time. Maybe it's very fast, maybe it takes 1 minute. You don't want your web application to freeze in the meantime, so this is asynchronous again, which means the fetch takes some time, and then when it comes back, you want to continue. And you do it that way. And let's first do that syntactically and then understand it a little bit more. So I'm writing a number of things here, which you may not, if you have not seen it before, fully understand. But let's just do it, and then I will explain it a bit more. And I will first explain on a simple level and then on a little bit deeper level. So this will take some time. And this means, very simply, do not continue this part of the code until this here has returned. In the meantime, you can do other stuff in the JavaScript, but wait for this. This part of the code is blocking and not continuing. There may be another line here until this fetch returned. So that's thing number one. Because I put a wait here, I have to say that this is an asynchronous function. And when you do the exercise sheet, you will have a lot of fun with this, understanding it, but you have to do this yourself. Just by reading it, you don't fully understand it. You have to try it out yourself, enjoy all the error messages, then you will understand. Now the funny thing is, this does not fetch the whole web page immediately. This first gets the headers. It will first give you back the headers, and once it has the headers, then you have to do something with the result, and you do that with then. And I will explain that too. I hope I can write it like this. And it's also written on the slides, I think. Yeah, then response, let's just do that. And as I said, yeah, this is not what I want. I want response, respond. Now what? There's a lot of new syntax here, right? Async, await, fetch, response, equal, greater. What's that supposed to mean? It's actually very simple. Let's now accept it for what it is, and I will explain it in more detail in a second. So what this is, just give me the contents of this. First the headers. If you get the headers, get the rest of the response. Interpret it, in this case not an image but text, that's what it means. And when this is all there, it might take some time, assign it to response, continue with the code. So that's on a high level what it means, and let's just log it on the console, and this is the response I got. And let's just see whether that works. So that's already... And so now we should see this search HTML query. We should see it here if I type something. Yes, please. Did I make a mistake?
Yes.
Yes.
Log.console, not console.log.
Yeah, I agree. Yeah, I was in the... Thank you. Any other mistakes before we try it? So let's... so I'm reloading my page here. Yeah. So now... let's see if I type something. I say we should now see a request just if I type a letter here. So watch this. I type, yeah, something happened. See? I got a request here. This is what the fetch did. Query equals D. I'm not typing search. Oh, by the way, this here is, I'm getting stuff I typed earlier. This is another small thing. There are a lot of these small thingies. How do you turn that off? You just say auto complete off, which means this stupid, yeah, the browser remembers what you typed previously. Let me just turn that off. Yeah, now. So now on the right here, you should see, look at this, a request whenever I type something. Yeah, see? That's what my JavaScript did. Whenever I type something, I now get a request. Now let's look at that request. What did I will go, let's first continue with a function, and then I go back explaining the JavaScript. The response is a whole HTML. That's what we did, right? In previous lecture, we returned the whole web page again. That's what you do in the static scenario. Now, I mean, the web page stays there. We don't want to reload the whole thing. We just want our result, right? Now we want our server to just return this. We don't need the whole web page again. It's still here. If you do this yourself, this takes some time to understand. How do we do that? I will give you the solution, but you have to do it yourself to fully understand and appreciate it. I don't want the whole web page again. So what I want now, I want a way to say, dear web server. So this is our small web server. It can serve whole pages, read files, return them, CSS, JavaScript, whatever. But it should also be able to just process my request. And for that, I just invent a new request, which I haven't. And a typical way to call this is API. API is when you have some, let me just enter API in the browser here. What does API mean? I mean, I could call it any way I like, but API is application programming interface. You talk to something, in this case our server here, and I have a language like here saying query equals something, give me back the n-grams for the query string. And that's a very simple API, so just some interface where I can ask certain things. I don't have to call it API. I know some of this is a bit fast, but I'm sure some things you will understand, others not, will become clearer when you do the sheet. Okay, so now I'm asking that thing. Let's just see what happens now when I reload, and now I type something, and now, yeah, thank you for API, auf Wiedersehen. Why is that? I mean, it's not what I, yes? Yeah, it's not I just API, it ignored the question mark, it's no file, and this is just, let's go to our code. It was just our fallback here. Else, this is not a file, just say thank you. Be polite, say thank you for this, I don't know what to do with it. So, we don't know what to do with it. Our code was like this. It said, if there's a query string, now let's do the following. If our request starts with, and now if I get this kind of request, API, no, we don't want API. AI suggestions, save typing, they're usually not what you want, but they do save typing. If I get this API question mark query, then I do all of the stuff before, and now actually I don't want to read the file or anything again. Let me just do the following, and I hope it's correct here, the query result. I don't want the, yeah, this is now my response, my whole response, what I get in the end, and I'm not sure I need the query any longer. Excuse me. A little break for my voice, and I will read the chat in the meantime and enjoy the code while I rest my voice. Oh, it was Robin answering to stuff. Okay, that's good. So, now, if I get this API request, I do this, my response will now just be the n-grams. This part, I do not have to do anymore. So if API, this is my response. If it's a file, this is my this response. If it's neither an API request nor a file, this will be my response. And now, does it already work? Maybe it already works. Let's just see. We can just try. Do we have to restart the server? Yes, because I changed the server code. These things are easy to get wrong, right? You change something in your server, you didn't restart it. You wonder, why is it not showing? Well, because you didn't restart your server. Let's just do that. Let's see what happens now. Doof. It worked. Now I get response 3 grams do. Wow, right? Now I get here these API requests. They just return my 3 grams. Mini change in my code, and I already get what I want. Actually, this 3 grams colon, I know I don't want that anymore. This is my program should just return this. So let me make that change. let me reload, type DOOF. Now I get here, now I get response here. Isn't that nice? So I get the query and I get the response. Let's change our JavaScript and not log the query anymore. I see that, and just so this is how you comment out stuff. So just do the response. Next thing, the console of the browser is for development. I actually want to add it back to the page. How do we do that? Well, on this page we had this result. We don't need this template stuff. We don't need it anymore. Let me just do the following. Let me write a paragraph here. Let me put there the query. And now I want something addressable where I put the query. There's span. So this is ID query. No, I don't want the query thing here. A span is just a piece of HTML. It's really doing nothing with it, but I can address it. So now if I want to change this particular part, I can just address it by hash query. And let's do the same thing for result. Result here, span ID result. And now let's just do the following. So this is my web page. I'm not reloading it. As soon as I get a response, I just change the query and the result thing here. And that's easy enough with what we already know. Let's just keep the response in the log for now. But let's also query. Yeah, let's first write, that was actually not bad. Query result inner HTML. Didn't want query result. I want to write the query. Just, wow, I should have figured that out. Query. And let's do the same with the, no, it's not called response, it's called result. I deliberately keep these suggestions on so that you see how off they are sometimes. They do help typing, but you can't accept them at face value. So that's simple enough. I got my response. I will come back to this, what this means exactly. I received my answer. I just changed the query and the response in the HTML. So I will just set these two spans, and I don't have to restart my... And now let's see. Not bad, right? Now isn't that pretty sophisticated web app, right? I already, just amazing. Okay, that worked. Let's go back to the slide. I will explain more about this. There's one more thing that's a bit strange, and I will come back to this in a second. I will also come back to this. Right now, what did I do in my JavaScript? Here's one more thing to do better. I built a string here and returned this as, I think, as text, right? The default is text plain. And actually I should see this in my web app somewhere. If I go to a network tab here and I type something D, so I send this request here. Let me try to make it a little bit larger. API query equals D, and if I click on this, then I should see, so I sent back text plain. But actually what I sent is an array, right? It's something structured, and you don't... So what I do right now, I create a string on the server side. Let me show that to you. Here I just create a string, and then I parse that string, or maybe process it further on my... Here I didn't parse it, I just printed it. But maybe I want to do something. It's an array, and I really want that as an array here in my JavaScript. So what we do now is we create a nice object here. So this was just a string. And actually, how does that... let's do the following. You don't like it? Not boring?
I've done like a lot of JavaScript.
Oh, he knows it already. Have a nice day. So, let's do the following. I now want to create a... I want to create a... How do I do that? No, that's not what I want. I want to join the n-grams, and I want to... This suggestion... So I'm repeating, this is a formatted string. I want a literal curly brace, so I have to do it like that. And now I want a curly brace. Let me make it a bit clearer. This is Python, so I think this is a bit more readable. Plus this, I join my qgrams. They already have quotes around them, and then I do this. And I don't need I could also use let's just see what this is doing. Let me just do that for a second. Restart the server. It should become clear in a second what I'm doing. And let's go to the console, type something here. And now I get why is it the empty array? I did something wrong. Join I think it's not, I need to type, So now my response is something that looks, actually it should be an array, not a array notation. So I'm constructing something that looks like a JavaScript array. This is what I want. I have to restart the server. In case you, So now I have an empty array, empty array. And now, so this is still text. Now I want my JavaScript to actually parse this as a JavaScript object. How do I do that? I just set the content type here to something JSON. So this is a JavaScript object. Does it mean JavaScript object notation? Is that what it means? Yeah. So I'm just telling my web application what I'm sending you here is not a string. It's actually a valid JavaScript object. And now we change something here. So we have to restart the server. And let's just do that. Go to the network tab. And now if I type something, I should see if I click on this here. Now it says application JSON. And now how do we see that? Let's just go to our JavaScript. It's actually logging the response here. Let me just see what happens. Go to the console, type DOOF. This is still showing as I think I should let me do the following. I just want to see that this is now okay, why am I not seeing this as
Passing it as a string.
Where do I pass it as a string?
In line 8.
So now right now I'm interpreting it as a string. Let's interpret it as JSON now. Thank you. I don't have to restart and I think then I can keep the response here, right? Let's just check it out now. And now it's actually, so now it parsed it as a JavaScript object, and that's what you should do. I mean, functionally it's the same like we did before. Now my Python server created something that's a valid JavaScript object. I send it as a JavaScript object, and now I don't have to write code for parsing it, right? Maybe this is a complex map with arrays and 1,000 fields. I don't want to write code for parsing this. I just want to say, hey, that looks like an array. And so now it's already in an array object. Which means here we could just do whatever. So what could we do here for the result? We could, can I also, we can join this, and maybe now I can join it with, not with a comma. Let's just do something for the sake of demonstrating something. Take the elements from, it's now an array. I don't have to parse it. This is already an array. Let me see whether this works and whether I now get these things with the pipe. Yes, I do, except that I hope you see the advantage. That's the only thing we did. We're now sending a proper, and here I'm also getting then as proper arrays. Okay. Before we go into the break, let me explain a few more things about that, and then we go on to the second part. Is there any question about this? So this is this JavaScript object notation. It's even written here. Yeah, so I can send that, and then that's what I explained earlier. Let me explain a little bit about this. I could explain a lot about this, but just a little bit about this part before we go into the break. And then think about it, and please do ask questions. You have a question already now?
If you type in quotes, because
quotes where?
like in the query, just know in the web app, if you type in quotes, is it escaped? Because wouldn't this mess up? Yeah, that's what I want to
Okay, that's not the escaping is not a problem, but that it's not a valid URL character. So this actually works. So yeah, if you are completely right. So here I'm just doing this very simply, and what do I do? Yeah, here I'm just putting it in quotes, and I'm not escaping quotes in there. So this will be malformed if I mean, this you would usually do with a library, like make a properly escaped JavaScript object out of it. So here I did it very simplistically, just putting quotes around each. If there's a quote in there, it will not. You're completely right. Okay. But for $1, it works. So I want to explain before the break this code here. And there's a lot. This is actually quite complicated in practice, but using it is not so complicated, understanding it deeply. Why is there async here? What exactly does the await means? What exactly does the then mean? That's from other programming language that's not familiar, I think, unless you know about coroutines and stuff. So let me explain this a little bit on the slides. But only a little bit. So here's something you should understand. JavaScript is single-threaded, not multi-threaded. And this is hard to understand because obviously things are happening at the same time in JavaScript, right? I could type something, wait for a request, and then in the meantime do other things. My web page will not freeze. What does it mean that JavaScript is single-threaded? It means even if you write a huge JavaScript application, at any point the browser will be just in one place in your code. It will not, you can't do multi-threading in JavaScript. That's what I wrote here. Yeah? At any given time, at most one line of your code is executed. But it may jump. So what it may do, and let me show that to you. Here it says fetch, wait for this. This might take a minute. In the meantime, it might execute other code, right? This it can do. So here it's waiting for something. In the meantime, something else happened. I clicked on this. There was another add event listener. I continue to execute that line of code. So this can happen, right? Execute here, there, but they are never executed at the same time, which helps a lot because if you have multi-threaded code, like a line here and a line here executed at the same time, accessing or maybe even writing the same variable, that opens a whole box of problems which you don't have in JavaScript. So that's one thing you have to understand. And what's confusing is it's single-threaded, but still asynchronous stuff is happening, right? So what is happening is that this is fetched to some other level, to the web browser, right? So the web browser now handles this stuff. And when this comes back, then it will tell the JavaScript, please, at the next possible occasion, continue your code here. It might not be somewhere else in the code. When this returns, please continue your code here. Now, what about this? And whenever you have something asynchronous, you just have to tell it. You have to say async. So here I have something fetch, take some time, come back to this line of code. When it's done, you have to put async here. If I don't put async here, I will get an error message. So yeah, if I just do this, now I should, await is only valid in async function. Yeah. So, in the meantime, other. So all of these, so async, await, then, we all saw this. So this means, this is what I just showed. So this means await. Let me just say that again. What does the await mean? It means this is now passed to the browser operating system. Wait for it to come back, but waiting doesn't mean that the JavaScript doesn't do anything else. It means I can execute other lines in my JavaScript now, because right now I'm not executing any more code here, because I'm waiting for something. At some point this comes back, that's what the await means, then I can continue JavaScript execution here. But I don't have to, right? It's the operating system of the web browser can decide when it passes control back to this one. So, and then I continue here, and what this then means, so once this call return, now do something, and let's talk about the then. So the result of this first asynchronous call returned, now go on. And that's also a bit confusing. Why this fetch and then? I don't go into any detail here. What happens is the fetch first returns the header, and maybe I just want the header. We have seen that, right? The response has these HTML headers. Maybe there's stuff I want to do based on the header, like not continue at all. Here I just want to continue. So this first gives me back the header. When this is done, then just do the next thing, and the next thing is also give me the body of the response. Response is header and body. And now this is a function call. And in disguise, let me show you that. And I go back to, so what does this mean? I could just have a function in here in the then. Function response, so I get the header. This is actually the, I think it would be clearer maybe to write body here. This is the body of the request. And I could also write it here and just interpret this body as a JSON object and give me a JSON object. This is very frequent. You have an asynchronous function with one argument, and then you do something simple with that argument. That's pretty verbose, and because that is so verbose, there's just a shortcut. This means this is an anonymous function with this argument, and the function should just return this. This is one-to-one this, right? It's just a shortcut for this. It's an anonymous function which takes this as an argument and returns this, because it's so frequent. So it's really quite simple, but again, a combination of many simple things makes it complicated. Also works for multiple arguments. Now, how is this all realized? I will not go into this at all. This is modern JavaScript, which I've shown you in the past. A lot of bad ways to do this. What this actually returns is a promise object. So the question is, this is just for the nerds among you, very, very quickly. What is happening here exactly? And could I also program this low level? What fetch returns, it actually returns something immediately, and it returns an object. So if you would just program this low level without await and async, you could. This actually returns immediately and returns a promise. And a promise is an object that has two functions in it. One function for what should I do if I'm done, and what should I do if I failed. Look at this if this interests you. That's actually how you implement this asynchronous behavior. You get something back immediately, and what you get back has functions in it, and these functions are called when something happens. Right? So you get this object, there are functions in there which are then called when either this succeeded or it didn't succeed. I think that's it before the break. Any questions before the break? Yes, please. Okay, let me explain a bit more. So if you would do this low level, this would execute immediately. You would get back the promise, and in the promise there are functions, and one function says, what should I do when this is done? And for example here, then this would be called. You would just say, when this is done, call this function. As I said earlier, this is a function. This is how it works. Actually, it's a lot of fun if you're interested to just do this yourself. Implement this via promises and see how it works. But it would go too far, cost too much time here.
I think what might be helpful to understand that then is that you can replace it again with an await. You can also say await response.json.
You mean this then part?
Yeah.
Yeah, okay, that's, I could, this is now a different level. He was asking about promises, which is the layer below. What you are saying is, I could do the following, right? I could do await, Yeah, I could do the following, yeah. This I could also do, but let's not. Okay, more about that after. Any questions before the break now? Okay, let's have a break and some oxygen. Meet back in 10 minutes. So, by the way, this vClock thing where we have ads, let me explain something to you, which we have seen a second ago. It's a manual ad blocker. This is a website, document object model. I click on inspect. I see the whole web page here. And I don't want that part. Let me just go there, inspect. I go here, this part, delete element, gone. Yeah, I can also modify with the development console everything on the web page. I can go here, inspect. What does it say? Set alarm, edit text. Beep, 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 beep. Yeah, that's document object model. I can also do it in the browser. Just within, it's actually very easy. I mean, not a lot of people know this. You do inspect, you can go, here's the whole HTML. I mean, that's all there. Thank you. I think, sorry for that, but we have some oxygen back in the room. Yeah, so I can modify pages anywhere I like, delete elements. Okay, this door does nothing, right? It's like, okay. I don't know, this noise level. Okay, anyway. So back to the topic. I didn't explain promises well. I just discussed briefly with Robin how this is realized on a low level. I was looking in the break for a one-sentence explanation. I once gave a whole lecture only about promises. I will think about a very short explanation how to. It's really fun if you are interested to implement it with promises low level yourself, but it's not necessary for the understanding in this lecture. Maybe I write something in the forum, like a very short for those who are interested. But it's really just what's underneath, what's behind these keywords. But with these keywords, it's much nicer to write, of course, but it's very interesting to understand how this is actually implemented in a low level. And let me say this one sentence again. You don't need these keywords to have this functionality. You could implement this in JavaScript yourself, this kind of behavior. Okay, so this we have all seen. Now let's continue with the last two parts. And before that, multi-threading. That's important for the exercise sheet. And let me say a few things. So first, does this still work? No, we crashed our website for some reason. No, we didn't. Okay. So what did our server do? It gets these requests, compute the n-grams. That's reasonably fast. So for the exercise sheet, let me briefly go to the... Should I go to the exercise sheet briefly? I think that's a good... Again, it's a lot of text because it explains. So this web application is you have all these Wikidata entities and you type something, the name of Wikidata entities with typos, just the prefix. That's what we did 2 lectures ago, right? You type the prefix, you even make typos and you still get the result. And this is something very common in web pages, right? You type something and you want to get a list of results. So that's the exercise sheet, and this we want to do now. And it's, so for example, if we go to our beloved Wikidata site, let's go here to the main page. You have something like this here. So if I do, yeah, it's something like this. You type something, you get this drop down, and so if I make typo here, I don't get any results. So we are already better than that for the sheet, right? So this is what you want. Now these requests, that's what we did 2 lectures ago. There we have this qgram index. It does something, and this takes some time. And now you have to understand what happens if I type very quickly here. And now each request takes 200 milliseconds. And I have a problem, and that's very typical for asynchronous applications. Here it's so fast that I don't have a problem. This is something to understand and think about. These requests are now executed concurrently. And you really have to you should understand that JavaScript is single-threaded, but if I have a lot of fetches here, they are passed to the web browser, and the web browser will do these things concurrently. In particular, I will, if this thing is multi-threaded, it can process 10 requests at the same time. However, our current web server does not do this. Let's just look at this code. This is just something to understand how about Python, one of the many weirdnesses about Python. If you go back here to this part of the code, which we haven't looked at all so far, it says, okay, I got a new request, go to this function. This is sequential, right? It's one request, I'm handling it, and then the next request. They are sequentialized. This is the place where a regular web server would just create a new process or a thread. Threads are like mini processes. I will not talk about threads now. So just, okay, here's a new request. Please go and process this, but continue with the program in case there's the next request. So when I get 10 requests very fast, I will just spawn 10 threads or little processes, and they will do that. Now the question is, how do you do that in Python? You can actually write it in one line in Python. We are not going to do that, but now you have a problem. Python is notoriously terrible. Actually, one could remove the add multi-threading part and replace with add a lot of things, but it's particularly notoriously terrible at multi-threading. And let me explain that very quickly to you, because, I mean, every serious language can do multi-threading, right? What does Python do? Python is an interpreted language. And this interpreter has one state, and like we have seen for JavaScript, you can only really execute one line of Python at a time, which means if I now have 3 requests executed at the same time, Python can't really do it, because this interpreter can only cannot do 2 lines of code at a time. There's more behind it, but it's like this interpreter is not by itself multi-threaded, which means it has a lock. Either I do this or do that. So I can't really do multi-threading. But there is threading in Python. How is threading in Python done? You will just duplicate the whole process, which means you have 3 queries at the same time. You want to do it with actually you can also do it in plain Python. And now it will just copy the whole process with all its data. Maybe your qgram index has 2 gigabytes, 5 gigabytes. You have 10 queries at the same time. Now you have 50 gigabytes, and you will see that. These are the funny things Python does. Yeah? So you use threading. You think, oh, cool, Python has multi-threading, and you duplicate your process with the complete data. Try it. It won't work. It will just crash your machine, because the qgram index is quite large. However, with 3.14, I mean, Python changes everything all the time. There is now a version. There are also ways to get this with earlier version. No GIL, and GIL is this global interpreter lock, where you can somehow get Python to not do this. So if you are interested, Robin, let's talk about it. Let's write a forum post about it. This is optional, but it's very interesting. Actually, with the latest version of Python, it's relatively easy. And then you can actually do multi-threading. And you will see it when you do the sheet. If you don't do multi-threading and you type very fast, you will have a problem. You will have the effect that you type and then nothing happens, because this thing, you type it in 50 milliseconds and then there you have this sequence of requests and they come back, not even at the same time, depending on what's first. Okay, new topic, 2 new topics for the rest of the lectures. Vulnerabilities. We have already seen this the last time, and let me just do up here. Okay, so let me just restart the server, and just to get into the mood of vulnerabilities again, you might remember this. I just type a path here, and I get a file from my machine. Last time it was the password file. Here's proc CPU info, not that bad. If I don't pay attention, I hope you remember that, I can access arbitrary files on my machine. I wrote my first little web server. I thought, cool, I serve my web application. Suddenly I gave the outside world a means to access all files on my machine. Not what I intended, and that's what's vulnerabilities. You write something, you don't think, you just think about what you want to do, and you have opened the door to bad things, like reading arbitrary files on your machine. And web apps, and that's just one example, I will show you more. It's actually a pretty cool topic, right? And you don't think about it, and this is how all these data breaches and whatever happens. You write it, you just don't think about it. Because it's, as I said, all the individual things are simple. In combination, it's pretty complex, right? Asynchronous, many machines, all these layers, HTML, JavaScript, Python server. If there's a question, please ask. So, here are some examples. Access to private data, code injection, we will see that in a second, and we will talk about all 3. This we have just seen, accessing a file you're not supposed to access. This is a big topic. A keyword, buzzword here is Open Web Application Security Project, OWASP, if you are interested, like a categorization of the top 10 vulnerabilities. There's a lot of stuff that go wrong. You can make a whole course only about that. If you have wait, back row, you have to, it's too loud if you talk, I'm sorry. Or you have to switch to a different frequency, which I can't hear. 20,000 hertz would be good for that. Then I can't hear it. So, this we have seen, etc pass wd. How do you fix it? You just restrict it. Last time we just, if there is a slash in the file name or backslash, don't serve it. Or if you want to be super paranoid, just have a whitelist. Only those files, everything else is go away. That's one way. Code injection. Let's do some code injection. Let's have some fun. I don't know if it... I'm curious. Oh, by the way, search. This search button. That's so 80s, so let's get rid of it. We don't need a search button anymore. We don't... So form is really just for understanding stuff. I don't need this button. I don't need this button. Let's just get rid of this bye-bye search button. Let's make the field a little bit, I also don't need these funny templates here. And let me make the size a little larger, maybe 40, why not? Okay. Works. Now let's have some, I'm typing something here. Let's put web page here, devil. I'm using the same one for click me. You see what I'm doing? Let me also put a little devil's face here. How do I do that? 1F, I think the devil is 608, not 666, and funny, right? So, you see what I did? I wrote HTML in here, and now I have actually it's a link. Just click on it. It's so funny. It doesn't change, so devil.com is, yeah, it's unchanged for, so funny, isn't it? Okay, but you get the point. So I write, this is not, again, it's not what I had in mind, right? I wrote something to type nice strings and not HTML. Why did it happen? And there's some Easter eggs in the new exercise sheet. I hope you will like them. Read the sheet carefully. If you don't find Easter eggs, you have done something wrong. So what did I do? And again, I have to say it again, it's so important. I didn't think about it. I said, just put the query here. What did I do? Replace the inner HTML with whatever I typed in the query. We've just seen it for the clock webpage, right? I just replaced the contents by something else. My query here is a piece of HTML, which is a link on which I can click. Well, it just puts the link here. So you can now do stuff like that. So this is funny. Why is it bad? Let me show you a few examples. So yeah, this is what we have just seen, just for fun. I mean, you can send someone a mail. Yeah, just click on this link, and then in the link there's code that's actually executed. So here I have JavaScript, which is you click on it, and it will do something. But now you will see, hey, there are script tags. I won't do this. Actually, if you do URL encoding, every character has a counterpart with percent encoding. So if you have such links, you should be careful. You should think about whether you click on them, and so on. So that's one vulnerability. Our forum, just imagine on the forum there is, it would just take this code. Yeah, I don't go to the forum and you just put script tags in it, which then execute some code. The point is you open this in your browser, and then there's JavaScript, which maybe does something, right? I'm not going into any details here. You could use this to, yeah, you are in your browser, in another tab you have your Gmail or whatever mail open, and there are some session cookies. We're not talking about cookies today, although that's a great topic too. I mean, executing code on your browser which you aren't aware of is obviously a bad thing. Strange things might happen. Here's one very important thing which I want to go a little bit more detail into, that same origin. And let's just do, before I go to the slides, do the following. Right now, we have been working on Tura. Tura is a river in Asia somewhere. That's one of our machines on 888. And understand that our web little server here did two things. It served the web pages. It also answered these ngram requests. Let's separate this now. Let me go to Amur, which is another river in Asia, and let me also run the web app there, which is a bit strange. Right now it's running here on two different machines. This could be two different programs. Right now it's one program really doing two things. And let me use the Tura thing for just rendering the pages, search HTML, JavaScript, CSS, and this for processing the queries, which is a common thing to do. These are two different things. I can actually do this pretty easily by here saying this one should not go to Tura, but to Amur, and I'm just running it on the same port here. So fetch gets a full URL. If I omit that part, it will just take the same one as where I'm currently at, which is Tura. We just didn't think about it. Let's do this. So now I should see a request over here. And let's just see whether that actually happens. So this is now Amur, a different machine, just a different machine. And these machines can be anywhere in the world. Yeah, and now I get these requests here on Amur. and it's actually computing n-grams, sending them back, but now I get this. I say, no, I'm not doing this. I am Tura 8888 and I'm getting something from Armor 8888. Something is not right here. I'm cross-origin, and this is like a whole big topic, super important and very annoying when you develop web applications. You have a lot of, because it's very typical that you have, if you do a complex web application, things run on different machines, and you want to make it work, and you get angry at your browser for this, and you want to say, make it go away, but it's actually good. It helps you, and you should understand why it's there and resolve it properly. Let me explain a little bit. So there's something, so let's take a random bank here, and let's, somehow you clicked on this, and this, the name of the bank actually has a C here. Comdirect is a bank where this is a C, and you went to a web page which has a K. So it's actually just mimicking the real web page. And now let's assume these people were so smart that they wrote all this code and now sending pages to the real, you enter your password, it sends a login request to the real bank, and now the real bank sends something back, but it's actually not the right page, right? And you don't realize it. You click on this, you don't realize that this is not the real site. So, yeah, if you are sending, it can be problematic to just allow arbitrary communication between different websites. You should explicitly allow it. There should be a mechanism for us to say, this is okay. Armor, result from Armor can be used for Tura. That's what this is about. We have to do it explicitly. And there's a lot more stuff to understand here. That would be own course or own lectures, but let me just show you this. You don't need this for the exercise sheet, you just run everything on the same server. So this course thing, cross-origin, does it mention course here? Course header, it mentions here, course header, access control, allow origin. And it's again, it's another of these components. By itself, it's super easy to understand, but it adds to the pile of so many things. So web application is really 30 simple things combined together give something really, really complex. And let me explain course header in a nutshell. So this is about cross-origin resource sharing. Different machines, I want to say, it's okay. How do I do it? Let me just, before I go to the slide, do it in the code. It's actually very little code if you know how to do it. When I return the result, here I set my headers. I will actually, the error message gave me a hint. So let me just add this header. Oh yeah, it's already, thank you. Let me just say, so I'm now on Armor. Let's just assume I know that. And let me just say, Tura 8888, you can use that result. So what this is saying is, if you are Tura 8888, then you can use that result, otherwise not. And actually, we don't need that for, we only need that for, I think I chopped off the API thing above, so actually it doesn't have to be, it's just API. I don't need that for the, I just need that for the API request. And let me just format this. I claim that just with this little line, and by the way, I think you should see it here. Yeah, let me just reload. I didn't restart the server yet. If I type something here, this is now red. And yeah, if I see the headers here, I'm sorry, this is so, maybe you can see it. Request headers. Where are my response headers? These are my response headers. Usually for real web apps you have 500 response headers. Here you have just 3. We should now see this additional header crop up when I restart this server. Now it gets even more complicated. I'm not restarting the server on Tura, which is just serving our pages, just the one on Armor, which is serving our API requests. Let's just see if that works. So many things can go wrong here. I type something, bam, it works. Should work now. Yeah, there's no, Yeah, it works now. Let's go on one of these requests here. And now I should see access control origin Tura 8888. Telling Tura can use this. So, is it important? Port, let me just put a different port here and start it again, just to, and you have to play around with this to fully appreciate it. Now it's again, let's see what it says in the console. It says, access control does not match. Yeah, it's 8889, I am 8888. Why is that? Different ports. On one machine you can have many different whatever running, and they might have nothing to do with each other. So you have to be specific. This thing on this port I allow. And what you can do, what was suggested to us by the AI earlier, if you're saying anybody can use my n-grams. I'm a very generous person. I say my n-grams are for everybody. I worked very hard to compute them, but anybody can use them. I mean, you type the string, you get the n-grams. What can go wrong? You can just say anybody who asks this server, who finds this server, can use the result. You just write a star. You shouldn't do that if you are a bank, but if you compute n-grams, it's okay. Yes?
But this is just a client restriction. So if we go
Yeah?
to the shell and from another computer and use curl or something else, we get
Absolutely. This is just web browser stuff. But so the remark was, this is just in the web browser a thing. If I'm in my network here, I can just access this, yeah. But of course, these machines usually run in private networks, and no, that's not, I mean, that's not necessarily true. You could access them like we saw last time with Telnet and so on, and then, yeah, but then you get just...
we can get hardly computed qubits.
You can?
You can access the hardly computed qubits from anywhere where the server is reachable.
That is true, but you don't have them in a web page where something happens, yeah.
But somebody else can
Yeah.
just spin up another server and use their server to request your server, and then we still use the resources.
Oh, that's a very interesting comment. So you could write something which just via Telnet or curl accesses this and make a web application. I have to think about that. That's a very clever comment, and I don't have a good answer right now. How do you protect against that? Very good comment. Okay, let's continue. So you have learned about cross-origin. Oh yeah, and by the way, JavaScript is exempted from this. You can load in the script tag. You can write anything, because it's very common that you just include libraries via something like this. So JavaScript is exempt from this policy, which you can use for all kinds of nasty stuff. And in fact, one of the early web standards, JSON-P, which is before the last millennium, or maybe not, maybe a little bit later, yeah, just in case you want to read up. There are so many weird things about. So there was actually a standard which exploited this exception here, but it's no longer needed. So now we have to switch to one last topic, which is quick but also relevant. Before we switch, any question about this? Super nice, many easy things are complex together web app stuff. Please do the exercise sheet. It's so much fun. I mean, frustration at first, which then turns into fun, which is one of the most important life lessons. So, you will have funny characters. We saw the devil's face. And how do you do that? It's just web application information systems. You have funny characters in all the funny languages of the world. How do you represent them? You have to understand that topic. It's so important. And it's actually, I explained some low-level things which are just very, very interesting. So for the longest time, the standard was ASCII. And let me just show you ASCII. Okay, here I have a black screen. Let me just switch to Vorlesung. The This is the ASCII table. ASCII is just 1 byte to encode all the characters. Not all the characters known on the planet fit in there, just these typical characters you use for typing programs, right? The typical characters, the Latin alphabet in lowercase and uppercase. So this is just 7 bits from 0 to 127. And now, for example, you want Chinese, Japanese, Arabic, whatever, it doesn't fit in there. How was this done before Unicode? Before Unicode, you had standards, so ASCII just defines the numbers from 0 to 127, so you are free how you interpreted the numbers from 128 to 255, and you just had different standards. So one very common one, ISO 88591, was just use the upper part for the typical European, so if we characters. So all the funny characters you have in European language. So if I go to the Wikipedia page, I should see them. There's probably a table here. Yeah. So these are the ones which you find in European languages. So funny German characters, Danish characters, whatever. Many of them, also not all of them, but apparently not enough space for all of them. So at some point you needed a solution, like one standard which covers not all, but almost all, including Klingon and languages like that. So, and that standard is called Unicode, and it's actually, there are standards which are a bit strange. This is a great standard, has really good ideas, nice and simple. Let me explain it to you really quickly. Simply have one number for every character, unchangeable, and here they are. So A gets the number 97. It's always good to be backwards compatible. If we go to, and this is the first clever thing they did, so the small letter I, in ASCII it's 97, in Unicode it's also 97. Very good idea not to invent new things here. Capital A, so all the super frequently used ones in computing get the same numbers, 1 byte. Now you have funny characters, still 1 byte, A. You give the numbers from the ISO 88591 the same numbers as they had in that. So E4 was also in ISO blah blah blah, the number 228. Now you have Greek alphabet. These get 2 bytes identifiers. So 945 does not fit into 1 byte, you need 2 bytes. Then you have stuff like, came a bit late, Euro, all the 2-byte codes were already given away, so 3-byte code. And then you have, all kinds of stuff which requires 3 bytes or even 4 bytes. But everything has a number, even icons or whatever symbols. So how many are there? Slightly over 1 million. So in hex it goes from 0 to this number. So 1 byte is definitely not enough, 2 bytes are also not enough for everything, so 4 bytes is good enough. So now how? Now you have the code point, you have a number for each character. How do you encode that? And now here are 3 different ways. Let me briefly explain them to you. Okay, 4 bytes are always enough. Let's always use 4 bytes for every character. This is the standard, it's called UTF-32. And it works, it's very easy, it's fixed size. You have 4 bytes for every character, but very wasteful, right? If your strings just use the normal computer characters, you're wasting 3 bytes because you actually just need 1. So simple but wasteful. There's UTF-816, which always uses 2 bytes, and whenever you use 4 bytes, you use 4 bytes. So that's used for Java, and it's one. Java is also this language which did, some of the design decisions are just atrocious, and that is one of them, using UTF-816. So you are wasteful, and it's not fixed size. It's like, there is this saying, the best of both worlds, and this is the worst of both worlds. This was just bad decision. And this is the other world where you just use as many bytes as you need. So if you just need 1, use 1. If you need 2, use 2, 3 or 4. So this is very space efficient, this is wasteful but fixed size, and this is just bad, and Java uses it. So, and that's the last thing we do. It's easy, but it's really important to understand. And then an example. How do you do it? How do you do the variable byte encoding? Let's assume our number for a character, it's one of these normal characters, is in this range, so it can be encoded in 7 bits. And then the UTF-8 code is just 0. So the 0 says this is a 1 byte UTF-8 character, and then the 7 bits. Now let's assume up to this number, so this 11, right? 2 to the 10 is 1024, 2 to the 11 is 2048, you know that. So all these code points I can write in 11 bits. And how do I put this in 2 bytes? As follows. So my first byte has 1, 1, 0, then the first of these bits, then the next byte has 1, 0, and then the other 6 of these bits. 5 bits and 6 bits. We will see in a second what's the purpose of those. It goes on like this. So this is up to 2 to the 16. I have 16 bytes now. Then I write it in 3 bytes. 6 plus 6 plus 4 is 16. And if I need 4 bytes, I write it like this. And these are my byte sequences. In principle, we could go on, also do it for 5 and 6 bytes. But this is enough for, here we have space for 2 million code points. There are only slightly over 1 million. So it never gets longer than 4 bytes, and that's in the standard. Understand a few things about it, and then we will look at one detailed concrete example, and then we are done. The nice thing about this, now imagine you are in a byte sequence and you know it's UTF-8 and you want to decode it. The problem now is you might be in the middle of one of these, right? You are in a byte sequence, this is UTF-8 encoded string, and you want to know how do I decode this. Since just looking at the most significant bits, I know where I am, right? That's what the standard says. If the 2 most significant bits are 1, 0, I know that I'm in the middle of a UTF-8 sequence, but not the first byte, because the first byte starts with some 1s and then a 0, and here it's no 1s, right? So if I encounter 1, 0, I know I'm in the middle, then I can either skip beyond the last 1, 0, 1, and I know I'm at the next byte, or revert a little bit and find the next one here. And these here are also unique. They tell me, okay, I'm either a single byte UTF-8 character sequence, a 2 byte one, I just count the number of ones, a 3 byte one, a 4 byte one. So that's a very nice and simple encoding scheme. Any questions about this? It has some nice properties. I'm sorry, a few more minutes and then we are done. I know the next lecture will be shorter. This is the last thing I want to explain. Give me 1 more minute. So, these ISO characters, they are, the code point is just the same as it would be in ISO 88591. And here's something I wanted to show you, and it's, that's what I said earlier. A very typical exam question, also in oral exams. Let me just show this to you. Maybe the question is A, how do I get the right UTF-8 for A? And I tell you the Unicode is 228. How do you do it? And let me show you the bad way and the good way. So let's put E4 here. And I want to know what's the UTF-8 for E4. So one thing I could do, it's a hex number, right? So what is E in decimal? Just the E. It's between 0 and 15. What? 14. Question? Yeah, 14. It's 14. What is 4 in decimal? 4. Which means this is 14 times 16, which is 224. I hope you can do 2-digit multiplications in your head. Plus 4 is equals to 228. So now you could do 228, and let me just write this in binary, right? So it has 1 to 8 in it, so the first is a 1 and so on. So it takes some time, but there's a faster way to do it. Each of these is exactly a 4-bit number. It's called a nibble. So a nibble is like half a byte, right? So that's called a nibble. So what I can do, so what is 14 in binary? 14 in binary is, there's an 8 in it, a 4 in it, a 2 in it. 8 plus 4 plus 2 is 14. It's 110. And let me move this a little bit to the... So turning a number between 0 and 15 into binary is very easy. Yeah, you should be able to do this in your sleep at 3 a.m. in the morning. Some people are still awake at 3 a.m. in the morning, I heard. Okay, so this is 1110, and this is 0100. And now you have the bit sequence, and actually that's, that's what we should have here, right? So this is the... So you have that bit sequence, and if you have that bit sequence, now you can just put it, you know how UTF-8 works, you get those bit sequence, and now you can turn those back into, let me also do that here, back into, so this here is 110, that's 12, and 12 is ABC, C in hex, this here is 3, so I know, so converting hex to binary is really easy if you know this, right? So this is C3, and this is 8 plus 2, so this is 10, which is A, and this is 1, 2, 4, 4. So we know C3A4, and voila, that's what it is, C3A4. So common exam question, something surrounding this. I give you the code point, you tell me the UTF-8 byte sequence, or vice versa. It's actually quite easy. If you don't understand about hex binary, you will do way too much work. And I think that's it. There's some more stuff I will briefly talk about in the next lecture. There's just one more thing. URL encoding, so if you have these things in a URL, you are only allowed certain characters. So for example, the A in UTF-8 is C3A4 in hex, so in the URL it will be this % encoding, and that's relevant for the exercise sheet. That's it for today. Bye-bye. We have time if there's another urgent question. You have one?
I have no question, just a request.
A request.
Regarding the vulnerability things.
Okay.
Usually what you'd want to do instead of using inner HTML is to use inner text, so you can be sure that only text is being set. But if you really need HTML, you should just use a library like .purified, which automatically filters out malicious script stuff.
Yeah, so Robin made a party pooper comment, which is totally appropriate. You should never do that, right? Inner HTML, because it gives rise to the vulnerabilities I showed you. But of course, I wanted to show you. That's why I used it. You should never write this code. But you can write it, and then bad things happen. But of course, with proper modification code, this will not happen. Any other questions? Okay, have fun with the sheet and see you next week. Thank you, bye.